walkthroughs.com Science 8. Chapter 4 Electricity, Magnetic and Heating Effects.
When an electric current flows through a coil wrapped around an iron nail, the nail becomes temporarily magnetic, attracting iron paper clips. This occurs because the current aligns tiny magnetic regions within the iron. When the circuit is opened, the alignment disappears, and the nail loses its magnetism. This experiment demonstrates how electric current produces magnetism. By exploring variations in the setup, such as changing the number of coils or battery strength, we can study additional effects like stronger attraction and heat generation, forming the basis of electromagnets and current-powered devices. Magnetic effect of electric current. When an electric current flows through a wire, it produces a magnetic field around it, making the wire behave like a magnet. A compass placed near the wire deflects when the current is on, showing this magnetic effect. Reversing or switching off the current changes or removes the deflection. This phenomenon is applied in many devices to produce motion, sound, and force. Examples include electromagnets in cranes, electric bells, motors in appliances, loudspeakers, magnetic locks, and maglev trains. Electromagnets. An electromagnet is a coil of insulated wire on a soft iron core that becomes magnetic when current flows and loses magnetism when it stops. Strength depends on coil turns, current, core type, wire thickness, and winding neatness. Use of electromagnets. Electric bells, telephones, buzzers. Electric motors in fans, refrigerators, loudspeakers. Heavy lifters like cranes. Separating magnetic substances from non-magnetic. Medical tools for removing metallic particles. Toys. Examples: a electric bell hammer strikes gong repeatedly via electromagnet and spring action. B. Lifting electromagnet crane lifts, releases metal safely when current is switched on, off. Heating effect of electric current. The heating effect of electric current occurs when a conductor warms up as current passes through it due to resistance, which converts electrical energy into heat. Collisions between electrons and atoms produce this heat. Heating elements, often made of nichrome, are coiled to increase resistance and efficiency. The heat produced depends on current, resistance, time, and wire properties. This effect is widely used in appliances like electric irons, heaters, kettles, toasters, and bulbs for everyday heating purposes. A electric bulb. A tungsten filament heats up to high temperature and glows, producing light. Argon gas protects the filament and increases its life. Electric appliances, devices like heaters, irons, kettles, and dryers use heating elements to produce heat for daily use. Safety measures. Excess current can cause overheating. Fuses and MCBs prevent damage. Electric fuse melts during high current, breaking the circuit. B. MCB automatically trips and can be reset. Industrial uses, electric furnaces, welding, and induction heating provide controlled heat for industrial processes. Sources of generating electricity. A source of electricity supplies power to run devices. Power stations generate electricity, while portable devices use cells and batteries. Voltaic cell converts chemical energy into electrical energy using two different metals and an electrolyte. It creates voltage due to differences between metals. Working. Charges flow through a circuit to operate devices until materials are used up. Applications. Used in torches, remotes, clocks, medical devices, and electronics. Dry cell. Uses a paste electrolyte with zinc, negative, and carbon, positive. Uses or limitations. Common in small devices but non-rechargeable. Rechargeable batteries are better alternatives. Rechargeable batteries. Rechargeable batteries are cells that can be charged and reused, saving money and reducing waste. They contain two electrodes and an electrolyte, allowing charging and discharging. They convert chemical energy into electrical energy during use. Common types include lithium-ion, nickel metal hydride, and lead acid. These batteries power devices like phones, laptops, cameras, and even electric vehicles. Over time, their capacity decreases, so they store less charge and require more frequent recharging after prolonged use.